In this video we will talk about how to program a network card in assembly on a PC without an operating system. We will be booting a PC over the network with our own binary file, essentially using a PC as an oversized microcontroller. I did this because I was interested how networking works on the lowest level, and to see what to expect the hardware will do for you and what as a programmer you must do to use the network. I imagine the process is similar when working with microcontrollers that have Ethernet PHY. We are booting to pre-boot execution environment. PXE stands for pre-boot execution environment. Now we are booting off the network. This is the message from our binary that just loaded, and now I will plug in the Ethernet cable. Our binary detected the link status change. I will now tell you about the setup we are using. We will need to set up the hardware and we will need to set up the software. On the hardware side of our setup, we will have one main computer and one computer that that boots from network. We will do all the programming on our main machine, send the boot code through the switch to the test machine, and control the test machine using USB to RS-232 converter. You will need at least two network interface controllers and the motherboard that has an integrated LAN on motherboard. You will need one short crossover cable. You will need null modem cable and an RS-232 to USB converter. On the software side of our setup, you will need to go to BIOS, enable the LAN, then you will need to go to BIOS boot settings and boot from the network. We will write our code in assembly, and for that we will need a text editor. A good choice is Atom text editor, and optionally you can install x86 language syntax highlighting. To compile our code we will need x86 compiler, and we will use the NetWide assembler. To boot our test machine we will need a trivial FTP server and DHCP server. For that we will use TFTPD64. To control our test machine we will need a serial console, and for that we will use PuTTY. When you run TFTP, run it as an administrator if you want your settings to be saved. This is a bug in TFTPD. Once you start TFTP, go to Settings. On the Global tab, select TFTP Server and the DHCP server. On the TFTP tab, select the base directory. We will tell our compiler to compile to this directory. On the DHCP tab, configure the DHCP and type the boot file name. This is the file that our NetWide assembler will output when it compiles our assembly code. Select OK and select your LAN controller. Now start PuTTY. Select serial connection, select the baud rate, and select the COM port. You can save your settings by typing in the name and pressing save. Now that our setup is complete, let's talk about theory. In theory, you can control any device with only 5 types of registers: status, control, command, data in, and data out register. Status register contains status bits or flags. Control register contains control bits or bit fields. In reality, status register and control register are usually combined in a single register. The difference between control and command register is that control register contains bits that control the state of the device, and command register issues commands that start procedures on the device. For the purposes of writing a Hello World program, we will only be using a single register and a single bit inside this register. This bit will tell us if the Ethernet cable is plugged or unplugged. Information about what registers exist inside this Realtek chip is available in the official datasheet. Now let me show you the code. We have 4 assembly files and we have 1 batch file. We use the batch file to compile our code to the boot directory for the TFTP server. We compile the assembly code as binary. That means that the code has no formatting. It's not an ELF, it's not a portable executable, it's not a COF file. It's just a binary file as it would appear in the memory of the computer. So we are booted in the 16-bit real mode. The BIOS loads us at this address. This part here is only necessary if you are using a floppy disk or a CD emulated floppy disk. This is where our loader starts. We initialize the serial port, we print out the Hello World message, we send the Hello World message to serial port, and then we call the procedure that works with the network controller. Also in this file we have the procedure to reboot on key press. In the print assembly file we have the print function that prints a string, and we have the query keyboard function that checks for key press and returns immediately. Very similar to this one is the serial ASM file. We have a function that initializes the serial port using the BIOS call 14 hexadecimal. We have a function that sends the data to the serial port. We use this to echo to our PuTTY terminal. And there's a query serial function that checks for incoming data and returns immediately. And now this is the main part of this tutorial. We have the LAN assembly file. First 2 directives include the print assembly and serial assembly, so we can use these functions inside these files. We define our message to send if the link status has changed. We define our network interface port numbers, and these are IO ports, they are not TCP ports. We define the offset for our register. We're using the media status register, and we define the bit inside this register as link B bit mask. So this code here is the most important part of this tutorial, because here we talk to the network card. First of all, we move to NIC base to DX register, then we add the MSR offset. Over here we read the I/O map at the DX address, which means we are reading the MSR register. If bit 2 changes, we print the message and loop until a key press. So now let's compile the code, reboot the test machine and see what happens. I will double click the batch file to run it. I will now insert and remove the network cable a few times. Please like the video, subscribe, and see you in the next one.